three particles P, Q and R lie on a line of greatest slope of a smooth inclined plane. P has mass 0.5 kilograms and initially is at the foot of the plane. R has mass 0.3 kilograms and initially is at the top of the plane. Q has mass 0.2 kilograms and is between P and R. See diagram. P is projected up the line of greatest slope with speed 3 meters per second at the instant when Q and R are released from rest. Each particle has an acceleration of 2.5 meters per second squared down the plane. P and Q collide 0.4 seconds after being set in motion. Immediately after the collision, Q moves up the plane with speed 3.2 meters per second. Find the speed and direction of motion of P immediately after the collision. So it's moving up, it's moving down. First we'll find out the velocities immediately before the collision. This is our positive direction. The acceleration is negative. This is the time, initial speed of P, initial speed of Q. We should use this formula. So velocity of P is 2 meters per second and velocity of Q is -1 meter per second immediately before the collision. Next, we should use the conservation of momentum. This is momentum, it's m times v, and this is the law for two particles, and this is for P and Q. These are the datas. Masses, initial speeds. Very important that these are vectors, so they could be positive or negative, and this is the velocity of Q immediately after the collision. We should substitute these datas, and after calculation we get that the velocity of P is 0.32 meters per second. It's a positive value, so the direction of motion of P is up. 0.6 seconds after its collision with P, Q collides with R and the two particles collide. Find the speed and direction of motion of the combined particle immediately after the collision. This is our positive direction. First we will find out the velocities immediately before the collision. This is calculation for Q. time, acceleration, and initial speed. We use this formula and we get that velocity of q is 1.7 meters per second. This is for r. This is important that time is 1 second because it's 0.4 plus 0.6. Initial speed is 0, so we use this formula and we get that its velocity is minus 2.5 meters per second. Now we should use conservation of momentum law. These are data, masses, initial speed, and the velocities immediately after the collision are the same because of the coalesce. They are moving together. We can substitute and we get that the velocity immediately after the collision is minus 0.82. It's a negative value, so the direction of motion is down.